So, welcome, folks, to the continuation of the Emergence Tech Talk series. I know we took a bit of a hiatus, but we are back and we have some very interesting things to discuss today. So, the topic of discussion today is going to be the work that all the awesome folks at Emergence have been doing on generating SQL and trying to achieve state of the art on that. I'm your host. My name is Vivek Haldar. I work with Emergence. And let's do a quick round of introductions before we dive into the details of the topic itself. Paul, why don't we start with you and then we'll go around.
Sure. I'm on the research team at Emergence. That's enough.
Jeremy, go ahead.
I'm also on the research team at Emergence, and I have had the pleasure of working with these two on SQL generation.
Yeah, so I can go next. I'm also in the research team, and I'm working with Paul and Jeremy on the text to SQL problem.
All right, fantastic. Thanks, folks. So, we're going to talk about this very in-depth blog post you authored. This is from December, so fairly recent, that talks about how Emergence has been approaching text to SQL, what the problem to be solved is. And we'll leave a link to that in the description below. So, Paul, let's start with you. Can you give us a framing of what the problem is, and why it's challenging? Why are we even interested in solving this?
Sure. Well, to frame the problem, somebody sitting at a computer says um, that they want some information out of a database. They might ask it in the form of a question, or they might ask for it to be presented in a table or chart. Um, Typically, what they ask for is ambiguous, so you have to figure out what they're talking about, and you could try to do that autonomously or with the human in the loop. You resolve whatever ambiguities, and now you land up with an instruction or query that is clear enough that you can try to figure out how to answer that by breaking it down. Potentially, one approach would be to break it down into steps or sub problems or smaller questions, if you will. And then to figure out how those things map to the physical structure and encoding of whatever your database is. In doing that, it's helpful to know a fair bit about the database and how the language relates to the entities, relationships, attributes, or properties that are in the database, and then how those relationships are implemented in the database, such as joins or whatever. Um, and so that involves having knowledge about the domain so that you can understand the vocabulary and relate it to the schema, and having a variety of data or information about the physical structure and encoding, ranging from everything you would see in DDL to specifics on how the data in columns is encoded or represented, and any issues in there like nulls, blanks, padding, case variation, things like that. So if you can figure all that out, you have a good shot at being able to get SQL that gets the data that can be presented to the user who gave the instruction or query.
Great. And clearly, this is a problem that has very wide application, right? Because if you can figure out how to convert natural language to a structured query like SQL, that unlocks so much business value because there's so many systems that do these kinds of analytics. They're often bottlenecked on, specialized technical analysts whose job it is basically to construct these analytical SQL queries. So that makes a
Yeah, I
lot of
could give you
sense.
I could give you a few high-level examples of that if you'd like.
That'd be great. Yeah, please.
Okay. So if you're going to do machine learning or predictive analytics on this data, you're going to bring an algorithm to bear on some of this data, and you have to figure out what data might be pertinent, and then you have to figure out how to query it, aggregate it, all this stuff. So this capability is really um, catalytic for those kind of endeavors because you can get, for example, an agent that does machine learning or predictive analytics and just let it talk to the data itself, explore what's in the data, hypothesize what to investigate, and then get the data by just asking questions of the data. It doesn't have to worry about being an SQL expert. It doesn't have to worry about many of those details. A second example, little higher level, is if you're interested in business intelligence, like dashboards presented by software like Tableau, for example. Um, Underlying those dashboards are sometimes very complex queries. And so if you can automatically generate those kinds of dashboards using this capability, you could make things like Tableau much more dynamic, and you could allow those more or less static dashboards to become front ends for drill down and discovery.
So that's a great framing of why this is even worth pursuing. So you want to unlock querying data in a structured and reliable manner driven by natural language. And that really opens up all these use cases, like you just mentioned, Paul. Now, if I were, say, a newbie AI engineer, uh, my first instinct would be, well, surely the models are now good enough at generating SQL from natural language if you just give them a good enough prompt. Um, and that could be a good first attempt. So maybe talk about why that naive approach doesn't work, because one way to look at all the work you've done is how to really make that reliable and have correctness and refine it and really bring all the domain knowledge in. So I guess I want to walk through this journey of how just a one-shot approach falls short. And yes, even though the models have a lot of world knowledge about SQL and how to generate SQL, you need much more on top of that. So let's start with that. So how do you approach this problem beyond just kind of trying to one-shot it with the model's SQL world knowledge?
Yeah, so you're exactly right. So, generating syntactically correct SQL is easy for modern language models. But writing SQL that reflects the business intent of the user in the context of potentially very messy databases is the hard part. So in real enterprise databases, uh, things are very messy. Column names are ambiguous. Relationships between columns may be implicit. Whatever kind of business logic is intended lives in that kind of institutional knowledge that might not be reflected in the query itself or the raw database. So if you just prompt a model to generate SQL for a given query, it will often produce something that looks plausible, but might be wrong in subtle ways. And that's pernicious because the subtle ways in which it is wrong aren't obvious to a user. They don't necessarily crash, but they might mislead you into thinking that the answer is correct. So we have an approach that kind of breaks this down into several parts. Instead of generating SQL in one step, we have a kind of agentic pipeline that first plans the query, will reason over the schema, interrogates the metadata, drafts SQL, critiques it, and then refines it iteratively.
So you need, what you're basically saying, Jeremy, is one-shotting, while it sounds tempting, is not enough. You need to bring a lot more detail, a lot more domain knowledge, and then really iterate and refine and have a full agentic loop over the SQL generation to get to a good enough level of correctness and quality. And yeah, let's dive into some of those steps. But Ayan, go ahead. You were saying something.
Yeah, I just to add to Jeremy's points, my take is that like regarding, I think first of all, like I'd like to say that instead of one-shot learning, I think we are referring to zero-shot in-context learning here. So one thing that I have observed is so natural language, the way people or users uh, with some business intention in mind usually asks these queries. But there is a lot of ambiguity in these in the natural language that is present even in these queries. And so there is this problem of linking concepts within a natural language query to the actual database fields or the values that exist in the database. But when we prompt an LLM, what happens is that the LLM tries to map those concepts as it is without linking to the actual schema in the underlying database. And so it might assume certain, like the domain of values for a column might be entirely different within the database than what I mean, the user who is asking the query may not be also aware of the actual domain of values for a column. And this is also a problem that has happened where the LLM assumes that whatever is asked in the query by the user, values exist in the databases in the same way, which is not true. And therefore, like this multi-step approach of breaking down the problem helps us in the sense that, let's say, we come up with a query, some very suboptimal query, generated SQL query. But again, like from the concepts, they may try to find the same domain, I mean, similar type of values that is mentioned in the query, but actually it can return a null value. So if it returns a null value, I think iteratively we should evolve the query that is generated so that I mean the LLM should probe the database to understand that what is the actual domain of values for the intended columns that are asked. So it's just from like experience of experimenting with these benchmarks and trying to solve this problem. That's what is I realized over time.
I'd like to follow up on what Jeremy and I were talking by taking on the state of the art directly. So when we apply thinking models with tool calling abilities, they can uh, query the database for the metadata. And that metadata is the data definition, which is the names of schemas, tables, columns, and some other things, but it's fairly superficial. In cases where that metadata is well done, very well done, or the database is very simple, a tool and the query is fairly obvious, tool calling agents do fine. When the query gets to 50 words and there are hundreds of tables with thousands of columns and millions or billions of rows, it takes a little bit more sophistication to succeed. Um, I agree with Ion that um, most real databases have a large variety of issues. For example, variations in case, padding, things like that, that require some sophistication in whatever approach you're taking of not just getting metadata, but also probing, sampling, things like that to understand the database. But then there's a little bit more to it than just having a tool run around and try to generate SQL. Um, you might get something that doesn't perform very well because it does things like uppercasing a column before selecting on it, which makes it have to scan the whole table, for example. Um, or produces a query that produces results that if a human being looked at it would say that those results don't make sense. It doesn't make sense for somebody to have 27 purchases and no money having been paid. That doesn't make sense, but you can easily land up with a result like that if the LM thinks or concludes that um, oh, to find out how much somebody's paid, I do this, that, and the other thing and look here and there. And those are plausible, but incorrect. So there's, it's not just to be successful here, it's not just um, getting a rich body of metadata, including knowledge of distributions, samples, and encoding and how data is encoded. It's also, it goes all the way through all that past query generation to common sense.
Makes sense. And just to relate back to the blog post, I think what you just described in the blog post is referred to as database interrogation. Is that right?
Right. Personally, I distinguish interrogation from probing. So interrogation is a more thorough and potentially a priori activity. Probing is more dynamic in the context of a given task, i.e., an instruction or a query.
Got it. Okay, so that is an interesting distinction in that there is a query independent phase where you're learning about, say, the tables or the database in general ahead of time before any queries have even come in. And you kind
Right.
of store that knowledge. And then there's a query dependent or a query specific phase where you do some more interrogation of the database or probing, but it's now specific to that query.
Right. You can leverage this metadata that you've derived via database interrogation and augmentation by documents or conversations with the human in the loop. So that becomes more or less a static, although potentially evolving body of knowledge about the domain in the database. But in the context of an actual query that you've never seen before, you might want to think carefully about is that a one to many? What am I going to do there? Have I looked at that? Because you might not have thought about that before in your anticipation. So you might want to probe it and investigate. Am I going to have an issue with this query? Or if I go with this, if I try to use this function on that column, am I going to have an issue?
Got it. Okay, so I also want to come to benchmarks and evals, which is a huge part of this. But before we get there, so let's talk about the other main technique mentioned in the blog post. So one was database interrogation or probing that we just talked about. And then the other one is metadata enrichment. So talk a little bit about this next step of metadata enrichment, why you need it, how it helps with SQL generation.
So when I use the word interrogation, I'm really thinking about the metadata enrichment phase. So we, in the case of Bird, for example, we interrogated the hell out of those databases. And with because we're in a benchmark context, we didn't want to pollute it with any human in the loop or, saying, oh, we have this database. We want to give it these documents about that domain so it understands the terminology better. We didn't do any of that. The interrogation was enough for Bird. So that getting rich enough metadata and leveraging the world knowledge of language models to understand the semantics independently of the physical representation was sufficient for BERT.
Emphasize one aspect of this whole metadata enrichment process is the part that can be done offline. It's very heavy, so it can be done once as overhead, and then the probing process for individual queries only needs to be done at inference time.
Correct. And BERT was also easy because it's small. A typical database there only had I think it was on the order of 10 tables, was about the largest, and I don't recall any of them having a million rows. Some might have.
So that's a great transition to talking about benchmarks and hill climbing. So obviously, if you set yourself the goal of, improving text to SQL, you need some benchmark to measure yourselves for hill climbing. And in the blog post, you talk a lot about BERT. But before we get into the benchmark itself, talk a little bit about what the landscape of benchmarks is out there, because there's BERT, there's Spider, there's a few others. What do the benchmarks look like? What kind of things do they test for? How are they different? And why did you end up picking BERT for this particular effort?
So the Bird SQL has many more examples. It has a mini dev set, a full dev set, and then a full test set with about, I think, 10,000 or so examples. So that's a plus. The minuses, in my mind, for Bird is one thing Paul mentioned, the structure and size of the databases we thought were less realistic, less aligned with kind of enterprise contexts. And then we thought there were some problems with the ground truths that Bird provided. Spider, on the other hand, the data set itself is much smaller. There's about 540 something examples in the entire data set. There's no hidden test set. So the dev set that they've released is the same as the test set, which has its own issues. But on the plus side, the database's size and structure is much more complex and realistic when we compare it to real enterprise databases. So there's kind of pros and cons of each one.
So I'd like to add more. I think Jeremy covered already the important points for the bird benchmark. But for the Spider 2 benchmark, what I find is that so there are 152 databases, and some of the databases have multiple schemas. So 152 databases and 272 schemas, and only 547 queries. And also these databases are like they are quite complex, and they resemble in some extent with real world industrial or enterprise databases, but some of them seems to be way too complex, which may not actually be in line with real world databases. Like some of them are quite complicated, and there are a lot of number of tables are huge, and some of them have similar structure, but it's kind of like they have data or rows belonging to different date ranges, like maybe logs from 2016 or 2017. So there are a lot of these tables, a lot of redundancy in the structure. Uh, Another thing that basically observed is that so we have 152 databases and only 547 queries, but if we consider the complexity of each database, we are not really looking into we're looking only at a very few queries in the entire possible query space, given the schema of a particular database, if we consider any one of them. So actually, like I would say like we're not really evaluating a large part of the query space for a particular database. And now I'm kind of questioning like whether it is feasible to judge or evaluate our systems just by looking at a handful of queries out of many possible queries that might be relevant for one of the databases out of those 152. Yeah, this is something that might be open for discussion, but yeah, I wanted to bring this into this um, into this discussion.
Yeah, Ayan, so that is actually a great next topic to discuss, which is that, okay, you looked at the landscape of benchmarks. None of them are perfect, of course. They each have trade-offs and pros and cons. And then you went with BERT. So talk a little bit more about this, the thing that Ayan was just mentioning in that, okay, Bird also has some shortcomings in that, and the blog post goes into a lot of detail on this, in that you feel that it doesn't quite capture the problem that you want to solve or the complexities or nuances of what SQL generation should actually be getting at. So talk a little bit more about that, and maybe after that we can talk about like in your ideal world.
Um, so Bird, I wouldn't say that Bird is not a good benchmark. It was very useful to just have a bunch of queries, even on fairly simple databases, to test our system. So that was really useful. And it suffers from issues that any real system would suffer from. Its main problem is that many of the questions are underspecified, including ambiguous. That's one of its main problems. It has some problems with ground truth as well, but I would say that its primary issue is a lack of really careful scrutiny of the queries so as to eliminate that ambiguity. And that's a tough problem. So I think any real system has to confront the inevitability of ambiguity.
I'm aligned with that. I think I would distinguish between a data set and a benchmark. I think Bird is a very useful data set. I think as a I think it's a less useful benchmark because some of the because of some of the issues that Paul and Ion raised.
So one of the things you talk about in the blog post is how you're seeing some evaluation issues and then some issues with baselines. And so you mentioned the data set inconsistency. So talk a little bit more about that, maybe as a segue into what do you think a good benchmark for enterprise text to SQL would look like? And I mean, do you think these benchmarks cover it, or do you think we need some kind of a new benchmark?
I don't see how benchmark, unless they're extremely structured, how benchmarks are really going to lead to excellent solutions in this space. I think you can measure yourself along some potentially narrow dimension with a noisy measurement result, but um, the proof is in the pudding. When you sit in front of one of these systems and it behaves well, that's hard to get into a benchmark.
I kind of feel that we are currently, since we are trying to evaluate our methods against benchmarks, it seems that we are making our system a bit restrictive in the sense that we are trying to optimize our system according to how it behaves or performs on a particular benchmark. But as a text to SQL, as a practical solution for text to SQL, I think we need to be more, I won't say generalized, but we need to be more capable or evaluate ourselves against multiple types of databases, or let's say there should be some generic properties of our system, but when we are evaluating against a particular benchmark, we seem to be optimizing the system to follow the examples in those benchmark or do well just on that benchmark. It's like it's a kind of limit. We are kind of limiting our system in some way. It is my opinion, but it seems to me that it may not be a realistic text-to-SQL solution if we perform very well on a single benchmark, but we don't know how this system might react to a new database or a new industrial, data repository, how it would behave. So I'm
Yeah.
quite kind of unsure what is the ideal scenario for the systems that we are building for text-to-SQL.
Yeah, I think that these kind of text to SQL or talk to your data systems. I don't think they're inherently resistant to some sort of rigorous evaluation, but I think the types of evaluations that are embedded in both the Bird SQL and Spider 2 benchmarks may not be the most appropriate. I think we need to kind of think beyond the text in SQL out or text in results of executed SQL out framework, because this introduces a bunch of problems on how should a execution result be evaluated for equivalency with an expected result. What does it mean for those two to kind of convey the same information? How do you treat extra columns? How do you treat, column names, formatting? The correct answer to a natural language query can be, can be found in many ways in many types of execution results.
So just to drill into what Jeremy just said, when you ask a question in English, you're not really specifying in most cases, the order or the names that might be assigned to the columns of the result set. That's a major problem in Bird and in Spider. Any fussiness about so if you have two semantically similar headings, but the evaluation procedure says, oh, they're different, but a human being would say, oh, I got it, that's it, yeah. But the evaluation procedure says no. Oh, that's too bad. And then if the evaluation procedure cares that you have two more columns that are really informative, and you thought the user might, your SQL generator said, well, I'm getting that anyway, I'll throw it in there too. Um, and you get dinged for that. That's not so great. And if you have a floating point number or something like that, that's off in the fifth decimal place because the benchmark guys ran it with some precision. They used doubles or floats or whatever they did. And the SQL generated it. They might have used a float instead of a double or a double instead of a float, whatever they use. Those kinds of things are annoying, right? Um, um, so and that's what I was talking about, that unless you go so far into the specification of each of the items in a data set, like you make that query, make it explicit that you want this column, that column, the other column, then you get into overly constraining evaluation procedures and artificial targeting of that evaluation procedure. I'd like to make and so what matters is the result set sufficient for responsive communication or presentation in some user interface, or sufficient for whatever algorithmic purposes that the query originated from, such as predictive analytics or a dashboard. That's what matters. And so, in a real talk to your data solution, it almost starts from the UX instead of from the database. and it comes back to the UX. And the result set is a mere technical artifact of the communication and presentation.
Right. And which brings us to the big question, which is, to the extent that you can share, what are you seeing in terms of applying this system in the real world with real systems? What has the feedback been like? What is the role of the human in the loop? Um, how is it going so far?
I mentioned in the beginning that that business intelligence, things like Tableau or dashboards, um, so we've engaged with large companies that have such things, and they want more agility than their current waterfall dashboard development, dashboard and report development processes are. They want to be able to get a new report or a new dashboard or a new Tableau pretty much now. They want it as fast as they can get it, and they don't want to pay tens of thousands of bucks to get it.
I would say that the one other thing that comes into play, when we actually apply systems like these in real kind of talk to your data enterprise context is uh, how well they perform is not a matter of hundreds of one-off queries, but might take into account kind of user preferences across queries. Say you have some feedback about the formatting of a certain answer. Next time you ask a query like that, the system should kind of know what you expect based on your past interactions with it.
Exactly. So the human in the loop is really more active in getting the presentation that they want than in clarifying the data model, because the person who gets the most value out of talking to the data is not the person that's interested in SQL. It's the person operating or strategizing at the business level. And they're not going that human in the loop isn't going to help you much in understanding the physical database.
I want to share a particular instance. I mean, kind of like, I think that the evaluation method that's being proposed, at least in Spider 2, that this is a flawed, in some way, a flawed method to evaluate. Like, because when we are saying that, yeah, there's some result uh, that's being generated by executing a SQL that we are getting from our system, and the expectation of the evaluation in Spider 2 is that there needs to be an exact match between two result sets. Now, like, let's say, like, the point that Paul mentioned about, like, the floating point operation or the precision level, right? There is a particular example where there's some field where the ground truth value is 0.013, and the model generated some SQL which on execution gave us 0.011. So due to this exact match criteria, this will be seen as a failure, this particular example. But interestingly, if we use an LLM critic to just tell us whether this particular result and the generated SQL, given the query, whether it looks good or whether it is acceptable or not, it it always, for these kind of like small value errors, it kind always seems to say that this is an acceptable result, or it looks good, and it is good enough as an answer. um, and the reason is that the LLM really doesn't think that small value errors or like these should make a SQL that is generated by the text to SQL system um, is a huge
Same
thing.
for just to interject, sorry, but same for column headings and order. It
Yeah,
it has
exactly.
it has enough world knowledge and I hate to say they have common sense, but I'm going to put that in air quotes. The language model can see, oh, those are obviously like a human being would.
Yeah,
That's the
exactly.
same thing, at least
I
for
mean,
small results. For small results'
yeah,
sakes.
yeah. I was gonna say even with the LLM judge, I mean, treating two numbers as kind of equivalent depends heavily on what those numbers represent. A 0.01 difference, might be treated as equivalent if that 0.01 represents, something in the real world, but something else, it might be very important.
Right. So you want to go to at least, I would go further than 3 decimal places. But again, this comes back to benchmark construction. If you had said, I want that as a percentage, and you judged it and you said, we're going to judge it to this degree. If you defined all that, that would be good, because at least then you'd know when you're looking at it, is that the same thing, despite numeric calculation variances. Um, but that's a very tedious process for a benchmark creator to go through.
And I guess the one other wrinkle in kind of equivalency evaluation that I saw come up a lot is whether the supporting information used to kind of generate the literal answer is included in the result set. So, take a simple example. If the natural language query is something like, uh, what are the top 5 basketball players by height, right? Should the result set include just the names of the top 5 basketball players? Should it include their heights as well? Uh, there's no definite
It's
answer
kind
to
of
that.
open-ended. It's
Yeah.
a bit open-ended, but these kind of evaluation which we have been doing following the eval suit, they will rate all these cases as failures, which is, I mean, it's up for debate. Like, what is the best evaluation method? I mean, we should come up with some evaluation approach which is fair in this scenario instead of.
It's hard. So they say, give me the top 5. What if there's a tie for fifth? What do you do?
You can
Yeah,
either
you
have
guys are
one of the
making
ones that has a tie, or you can give all the. I mean, let's say there's a tie for the fifth one. Like you can return both, but either of them, is it incorrect, or can you say that not giving all the ones that are tie is
Exactly.
an.
So if you just return 5, it's a coin flip as to whether or not you uh, score on the benchmark.
right. So
Yeah.
you're getting at how like interpretation and maybe subjectivity plays into evaluating these results. Um, and yeah, I will refer people to the Emergence blog. You guys have been on a tear lately, publishing so much technically deep material on the blog. Um, to wrap up, say a little bit about what next in this work stream. What are the next big challenges you're looking at or problems you want to solve?
So the path I'm interested in is not just in data intelligence, which is mostly what we've been talking about, and substantially accelerated, if not automated, business intelligence, to insights, which so most business intelligence doesn't have a lot of dynamic drill down. As you get beyond more static or anticipatory business intelligence, such as Tableau and other dashboard type software, and you look to how rapidly you can try to gain insight yourself by probing through drill down or other ad hoc questions, or by taking the next step where this AI knows something about the company's operation, its KPIs, its strategies, its competitive market, and now it knows a lot about the data. So it can look on its own for insight. You can bring machine learning algorithms, predictive analytic algorithms, and other algorithms to bear automatically and go to scale and at scale try to discover. That's what's really interesting to me, and even beyond. So now, so suppose you really understand the data and you want to optimize an operation. You might want to use some system of equations or a nonlinear problem solver and set it up and feed it the data. All this can be automated, but it comes back to the requirement to really understand the data. And then the next interesting area is to understand how that data pertains to the operations and opportunities of the enterprise.
The work that I've been doing in a slightly different context on root cause analysis kind of relates to the SQL and talk to your data stuff as well. Uh, when users are asking, asking questions about data, they're not doing it in some disembodied way. They're doing it kind of in the service of some larger analytic intent. So, determining the root cause of some failure might involve lots and lots of, targeted data queries that need to be, the results of which need to be synthesized into some coherent analytic result. That's kind of taking the individual cases and kind of marshaling them to some larger purpose. That's what I'm kind of interested in.
Yeah, so I'm slightly different thing I'm looking to, I mean, investigate, you might say. Like I'm looking to set up an evaluator like for text to SQL systems, and this is something like I'm working with Prahlad in collaboration. And this came up through one of our discussions on this text to SQL and whether like the current evaluation suits that we have in these benchmarks is the only way to go about it or not. So we're looking at finding the best way to evaluate or the fairer way to evaluate. So for instance, I'm working on building an evaluator that is optimized on let's say there's some ground truth results for some of these queries. So, and if we could optimize an evaluator in such a way that it gives high scores on the ground truth results, because those are the golden result sets and those are expected to be correct. And we can use that same optimized evaluator to basically rate the generated result sets, like the predicted result sets from our systems. Then we can say that this particular evaluator is a good source to judge the performance of our system, instead of like a simple exact match or having such a restrictive evaluation method. So this is just one method, but yeah, like I think we should come up with some evaluation which would seem more realistic in the enterprise scenario. Is one interest that I have in order to have some progress on these approaches. I think that might help us in a lot of ways. Like even like we are now working with the benchmarks, but if we try to productize this text to SQL, we would perhaps it would be better to have a realistic evaluation instead of like this highly constrained, yes, or like an evaluation which is highly overly restrictive and these points that we discussed, right? Like the pros and cons, like it definitely has a few cons involved. So yeah, that's something that might be interesting to get to.
Yeah, we should mention that talk to your data is primarily driven by select statements where you're pulling data out of a database. Um, uh, Ion just mentioned a member of our data intelligence team, and in the context of one of our clients, they had massive point of sale data that they aggregated and to make certain other queries efficient. And our data intelligence team looked at the raw data metadata and the target metadata and could understand why they were performing that aggregation and identified automatically deficiencies in the transforms that they were using, and are able to not just select, but to transform, which means to create a database and write the SQL that will take data from one database and put it into the other database. So it's not just read, there's also write. And when you have those capabilities to create data, to understand what the target data model is, then you empower agents such as we work with another client on monitors. They want to tell customers, patients actually, when some environmental factor might have an impact on their care, like the potential for a power outage due to anticipated storms or severe temperatures affecting somebody who requires some kind of home machine, whether of whatever kind, could be dialysis. I have no idea. That agent. So if you wanted to solve that with an agent, that agent is going to want to remember that who needs to receive these alerts. He's going to want to remember where he's found news on the web, and he's going to want to remember what alerts he's sent. And so either somebody's going to have to do all that and write the databases and all the code to get it, or the agent can do it itself. Both define the data model that the agent requires, and then populate and manage that data.
Right. So that has been a fascinating and deep discussion. So thank you very much, folks. That's a good note to end on. I hope everyone enjoyed that, and we will see you next time. Thank you very much.